everyone, and welcome. My name is Vincent Orlanes. Today, we're going to dive into a topic that affects all of us fatty acids. I would like to ask you, what have you observed with the structure or picture presented to you today? Those two pictures are fatty acids. As you can see, the other one has double bonds, and they are unsaturated fatty acids, while the one with no double bonds is a saturated fatty acid. Understanding fats goes beyond just counting calories. It's about understanding the molecular structure and how that structure impacts our health. At the end of the lesson, the student will be able to define saturated and unsaturated fatty acids, differentiate between saturated and unsaturated fatty acids by the presence and type of double bonds, describe the physical properties of each type, and explain the effect of double bonds on the shape and function of fatty acids. We'll start with the basics. What exactly is a fatty acid? Simply put, a fatty acid has two parts, a carboxylic acid and a long unbranched hydrocarbon chain. Think of it as a two-part molecule. First, you have the head, or the carboxyl group. This is the acidic part. It's polar and loves water, which is hydrophilic. Philia means love, and hydro means water, which means it loves water. Then you have the tail, or the hydrocarbon chain. This is the fatty part. It's a long chain of carbon and hydrogen atoms. This tail is nonpolar and hates water. It's hydrophobic. Hydro means water and phobia means fear. Therefore, it hates, fears, or avoids water. Fats often get a bad reputation, but they are very, very crucial. Without fatty acids, our cells wouldn't have membranes and we wouldn't have the energy reserves needed for daily life. These molecules are absolutely vital for life. They serve as efficient energy storage primarily as triglycerides. They are also essential structural components of our cell membranes and they act as precursors for hormones, provide insulation, and protect our vital organs. Now, we will classify fatty acids based on the bonds in that hydrocarbon chain. The first type we'll discuss is saturated fatty acids. The key characteristic here is the structure. Saturated fatty acids contain only single bonds in their hydrocarbon chain. This means they are saturated with the maximum possible number of hydrogen atoms. Because of these single bonds, the molecules are straight and linear. They can pack together very tightly like a stack of straight straws. This tight packing leads to strong intermolecular forces. It takes a lot of energy to break these forces, which is why saturated fats have higher melting points. The result? Saturated fats are typically solid at room temperature. Think of butter, cheese, or the fat on a piece of steak. They're found in red meat, full fat dairy, and processed meats. Interestingly, some plant-based oils like coconut and palm oil are also rich in saturated fats, even though they might be liquid at tropical temperatures. When it comes to health, the primary concern with saturated fats is their impact on cholesterol. A high intake of saturated fats tends to raise our levels of LDL cholesterol, often called bad cholesterol. High LDL levels are associated with atherosclerosis, the plaque buildup in arteries, increasing the risk of heart diseases and stroke. You can see in the table, saturated fatty acids do not contain double bonds. They only contain carbon and hydrogen atoms. In order that you can memorize more the number of carbon atoms in each saturated fatty acid, you can just add the first number with the number 2. For example, butyric is 4 plus 2 is caproic plus 2 is caprylic. So let's do it again. Butyric is 4 plus 2 is 6, so it's caproic. Plus 2 is 8, so it's caprylic. Plus 2 is 10, so it's capric. And so to organize these acids or fatty acids, you can just use this mnemonic instead. Big cats can climb large mountains, proudly standing at bright lakeside cottages. Next, we have unsaturated fatty acids. These are fundamentally different because they contain one or more double bonds within their hydrocarbon chain. These double bonds mean the chain has fewer hydrogen atoms. More importantly, each double bond creates a structural change, a kink, or a bend in the fatty acid chain. These kinks prevent the molecules from packing tightly together. Unsaturated fatty acids are categorized into two main types: Monounsaturated fatty acids only has one double bond from the word mono, while polyunsaturated fatty acids has two or more double bonds, which means from the word poly itself. Because of those kinks, unsaturated fats have weaker intermolecular forces. They don't align closely, which gives them a distinct physical property. This makes them have lower melting points and typically liquid at room temperature. Unsaturated fats are widely recognized for their health benefits. They are known to help lower LDL or bad cholesterol, reducing the risk of heart disease and stroke. Omega-3 fatty acids, in particular, are vital for brain health and have strong anti-inflammatory properties. You find this in fatty fish like salmon, flax seeds, and walnuts. Monounsaturated fatty acids are abundant in avocados, olive oils, and nuts. Unsaturated fatty acids have more double bonds rather than your saturated fatty acids. Fun fact, did you know that oleic acid is the most common fatty acid in natural fats? So that we can think about the difference between a stick of butter and a bottle of olive oil, we can differentiate them using solid versus liquid. Since unsaturated fatty acids have bends or have weak intermolecular forces, they tend to not create a tight pack. This makes them liquid rather than solid, which has a very strong intermolecular force. This makes them very tight, like packed straws. This makes them solid. We can now summarize these key differences, and I will ask you questions and you can answer them. Structurally, saturated fats are straight and rigid. Unsaturated fats have bends or kinks. Saturated fats are straight and rigid, and they are packed like straws. Therefore, they are what in their physical state? Solid. You're right. However, unsaturated fats have bends or kinks. They have weak intermolecular forces. Therefore, in room temperature, they are liquid. If you answered liquid, then you're right again. There's also a difference in stability. Saturated fats are more stable and have a longer shelf life because they lack those reactive double bonds. Unsaturated fats, especially polyunsaturated fats, are more prone to oxidation and can go rancid quickly when exposed to air, heat, or light. And most critically, their health impacts differ. Saturated fats increase LDL or bad cholesterol, while unsaturated fats tend to lower LDL or bad cholesterol and support overall heart and brain health. We need to discuss one more critical process, however, which is called hydrogenation. Hydrogenation is an artificial process used to convert unsaturated fats into saturated fats by adding hydrogen atoms to the double bonds. This process is used by the food industry to improve texture, shelf life, and heat stability. As we all can remember, as what I have said earlier, saturated fats lack reactive double bonds, which makes them more stable and have a longer shelf life. By adding hydrogen atoms and taking out these double bonds, hydrogenation makes the shelf life of a certain type of fat longer. For example, complete hydrogenation eliminates all double bonds and lengthens the shelf life of a saturated fat, while partial hydrogenation eliminates only some double bonds. The issue with partial hydrogenation is that it often creates trans fats. During this process, the natural shape of the unsaturated fat is altered, creating a straightened chain that acts chemically much like unsaturated fat. Trans fats are the most dangerous type of fat for health. They don't just raise LDL or bad cholesterol. They also lower HDL or good cholesterol, increase inflammation, and promote insulin resistance. These effects significantly increase the risk of heart disease. Because of these severe health risks, many health organizations, including the Food and Drug Administration, have effectively banned artificial trans fats from the food supply. If you have ever seen partially hydrogenated oils on a food label, then you can consider it already as a red flag. While these fats made snack foods and margarine last longer, the health cost was too high. This is why we need to be careful about what we consume. In conclusion, both saturated and unsaturated fatty acids are fundamental components of our diets and our biology. The structure of a fatty acid, specifically the presence or absence of double bonds, determines its physical state, such as being liquid or being solid, stability or their shelf life, and most importantly, its impact on our health. Unsaturated fats, particularly those in their natural cis configuration, are generally beneficial for cardiovascular health, while saturated fats, and especially artificial trans fats, pose significant health risks. Understanding this relationship between structure and function empowers us to make better nutritional choices. By choosing healthier fat sources, we can support our long term well being. Before we end, questions will be presented in the screen to know if you actually have learned in this topic, and you must answer them in the comment section below. Good luck! I am your instructor, Vincent Orlanes, and I hope you learned a ton from this topic.